First contact gone wrong. The massive biomechanical ships of the Nexari darkened Earth's skies on a quiet Tuesday morning. Their arrival wasn't the invasion humanity had feared, but rather something far more intriguing, a desperate plea for help. Dr. Sarah Chen stood in NASA's primary control center, studying the intricate patterns of the alien vessels through the facility's most powerful telescopes. The ships weren't just technological marvels. They were living things, a perfect fusion of biological and mechanical engineering that made Earth's most advanced technology look primitive by comparison. "They're dying," she announced to the assembled team of international experts. "Their ships are failing at the molecular level." The Nexari themselves were equally fascinating, crystalline beings whose bodies naturally conducted energy and information, evolution's answer to living computers. Their civilization had achieved technological perfection centuries ago, or so they believed. But now that very perfection threatened their extinction. Admiral James Harrison, Earth's designated diplomatic liaison, faced the Nexari high engineer across a hastily arranged conference table at the United Nations. The alien's crystalline form shifted colors as it spoke, its universal translator converting complex energy patterns into human speech. "Our biomechanical systems are experiencing unprecedented degradation," the high engineer explained, its form flickering between deep blue and violet hues. "We have tried every possible solution within our technological framework. None have succeeded." What the Nexari couldn't say, because they didn't understand it themselves, was that their very approach to technology had become their greatest weakness. They had achieved such precision, such perfect integration of biological and mechanical systems, that they had engineered away their ability to adapt. Dr. Chen's team made the discovery within the first 48 hours of studying the Nexari ships. "Look at this," she said, pointing to a molecular scan of the alien hull material. "Their engineering is perfect, too perfect. There's no redundancy, no room for error or adaptation. When something goes wrong, the whole system starts to cascade towards failure." The Nexari high engineer's color shifted to a deep red when Dr. Chen presented her findings. "You suggest our perfection is a flaw." The concept was almost incomprehensible to their rigid thinking. "Not a flaw," Dr. Chen corrected carefully. "A trade-off. You sacrificed adaptability for efficiency, but living things need to be able to change, to evolve. Even mechanical systems need flexibility." The first major ship failure occurred 3 days later. The massive vessel's biomechanical systems began to break down, its living components dying while its mechanical elements seized up. The Nexari crew, despite their advanced knowledge, could only watch in horror as their ship began to die around them. But where the Nexari saw hopeless deterioration, human engineers saw opportunity. Dr. Chen led a team of Earth's best minds in developing an emergency response. Their solution was something the Nexari would never have considered: deliberate imperfection. "We need to introduce controlled chaos into their systems," Dr. Chen explained to Admiral Harrison. "Create gaps in their perfect molecular structure, spaces where the system can adapt and evolve. It goes against everything they believe in, but it's their only chance." The Nexari high engineer's crystalline form almost shattered when they proposed the solution. "You want us to deliberately damage our ships, to introduce inefficiency. We want you to give your ships room to live," Dr. Chen replied. "Your technology is amazing, but it's too rigid. Sometimes the strongest structures are the ones with built-in flexibility." As the first ship continued its terminal decline, Earth's engineers worked frantically to prove their theory. They had to convince a species that had spent centuries pursuing technological perfection that their salvation lay in embracing imperfection. The fate of an entire civilization hung in the balance, and humanity's greatest minds faced their greatest challenge: teaching an advanced alien species the value of taking a step backward to move forward. The engineering challenge. The next 72 hours at NASA's Integrated Alien Technology Center transformed into a global marathon of human ingenuity. Engineers from every corner of Earth joined the effort, their diverse approaches to problem-solving becoming humanity's greatest asset. Maya Patel, a materials engineer from Mumbai, made the first breakthrough. She had been studying the molecular structure of the Nexari ship's outer hull when she noticed something that the aliens had overlooked in their pursuit of perfection. Their material composition is flawless, she explained to Dr. Chen, her hands moving animatedly over the holographic display. But that's exactly the problem. There's no room for the structure to respond to stress, no way for it to heal or adapt. The Nexari watched with barely concealed skepticism as Maya's team began experimenting with Earth's primitive materials. They introduced carefully calculated imperfections into samples of the alien biomechanical compounds, creating microscopic spaces that could accommodate change. Dr. James Cooper, a biologist specializing in extreme environments, contributed another crucial insight. Look at how Earth's organisms handle stress, he explained to the Nexari high engineer. Living things don't try to be perfect. They build in redundancies, backup systems, the ability to adapt and evolve. The alien's crystalline form flickered with uncertainty. Our systems were designed to eliminate such inefficiencies, and that's why they're failing. Dr. Cooper replied gently. You've engineered away your ability to survive the unexpected. In a makeshift laboratory in Kenya, Dr. Amara Okafor made another vital discovery. Her team had been studying how certain African plants adapted to extreme weather changes. She saw a parallel with the Nexari's technological crisis. These plants don't just survive. They thrive by being flexible, she explained during a global video conference. They bend instead of breaking. Their imperfect structure is actually their greatest strength. The first prototype of the human solution came together in a collaborative effort that spanned 6 continents. They called it the Adaptive Interface Matrix, a seemingly crude modification by Nexari standards, but one that could potentially save their civilization. Young engineers like Tom Chen, no relation to Dr. Sarah Chen, worked alongside veteran scientists, bringing fresh perspectives to age-old problems. Tom's experience with experimental computer networks proved invaluable in understanding how to integrate flexibility into the rigid Nexari systems. Think of it like teaching a perfect machine to improvise, he explained to a group of bewildered Nexari engineers. You need to give it room to make mistakes, learn from them, and grow. The Nexari's response to the prototype revealed another challenge: cultural resistance. Their society had spent so long pursuing technological perfection that the very idea of intentional imperfection seemed heretical. Your solution is inelegant, the high engineer stated, its crystalline form shifting to a deep purple of disapproval. But it works, Dr. Chen countered, pointing to the test results. The modified systems show a 300% increase in adaptability and self-repair capabilities. The true test came when they applied the first modification to a small section of a failing Nexari ship. The results defied the aliens' predictions. The imperfect section began to stabilize, its biomechanical systems finding new equilibrium in their carefully engineered flexibility. Yet even as the evidence mounted, many Nexari remained resistant. Their rigid thinking patterns, so similar to their rigid technology, made it difficult for them to accept such a fundamental change in approach. It took Dr. Chen's team implementing successful modifications on 3 different ships before the Nexari Engineering Council finally admitted that the human solution, despite its seeming primitiveness, might be their best hope for survival. Perhaps, the high engineer conceded, its color shifting to a thoughtful blue. We have something to learn from your species' embrace of imperfection. As the human engineers began scaling up their solution, preparing to modify the entire Nexari fleet, they discovered something unexpected. The adapted sections of the ships weren't just surviving. They were evolving, developing new capabilities that even the Nexari hadn't anticipated. The implications were staggering. Humanity hadn't just found a way to save the Nexari ships. They had potentially unveiled a whole new approach to biomechanical engineering, one that combined the best of both species' technological philosophies, crisis and innovation. The crisis struck without warning. Across the globe, Nexari ships began experiencing catastrophic system failures at an accelerating rate. The modified sections remained stable, but they represented only a small percentage of each vessel's total structure. Time was running out. Dr. Sarah Chen stood in the Central Command Center, watching as red warning indicators multiplied across the global monitoring system. Each light represented another critical system approaching failure, another step closer to the potential loss of millions of Nexari lives. The degradation is spreading faster than we can implement the modifications, Maya Patel reported, her voice tense but controlled. At this rate, we have less than 48 hours before the largest ships begin total system collapse. The Nexari High Engineer's crystalline form had taken on a deep, pulsing crimson, a sign of extreme distress in their species. Our council remains divided. Many believe your solution will ultimately destroy our technology rather than save it. Tom Chin, who had been quietly working at his station, suddenly straightened. "What if we let it?" he asked. The room fell silent. The young engineer's fingers flew across his holographic interface as he continued. "We're trying to save their ships as they are, but what if that's the wrong approach? What if we let the systems fail in a controlled way?" Dr. Cooper caught on first. "Like a forest fire," he said, eyes widening. "Sometimes destruction is part of the natural cycle of renewal." The next 12 hours transformed into a race against time as the team developed their most audacious solution yet. Instead of fighting the system failures, they would guide them, using the degradation itself as a catalyst for transformation. "Think of it like controlled demolition," Tom explained to the skeptical Nexari Council. "We're not just introducing imperfection, we're creating space for your technology to rebuild itself better than before." Dr. Okaffer's research proved crucial once again. In nature, systems often need to break down completely before they can evolve, she explained. The death of old growth makes room for new life. The Nexari resistance reached its peak when they presented the full plan. The idea of deliberately allowing their precious technology to partially fail seemed like madness to their perfect, ordered minds. Yet as more ships approached critical failure, they ran out of alternatives. The first full-scale test took place on a smaller vessel whose systems were already near collapse. The human engineers, working alongside the few Nexari who had embraced their approach, initiated what they called a controlled reconstruction cascade. For 6 terrifying hours, the ship's systems appeared to fail completely. The Nexari crew watched in horror as their perfectly ordered technology dissolved into chaos. But within that chaos, something remarkable began to emerge. The adapted sections they had previously modified served as seeds, providing templates for a new kind of biomechanical integration. The ship's systems didn't just recover, they transformed, becoming something neither human nor Nexari engineers had fully anticipated. "It's beautiful," Maya whispered, watching the molecular scanners display. The new structure retained the Nexari's precision, but now featured built-in adaptation mechanisms, subtle imperfections that made the whole system more resilient. The High Engineer's color shifted through a range of hues never before seen in their species, the equivalent of stunned awe. "It is alive," they said, "truly alive, in a way our technology has never been." Success bred success. As more ships underwent the controlled reconstruction process, each transformation brought new insights. The adapted vessels proved more capable than their original designs, able to repair and even improve themselves in ways the Nexari had thought impossible. Dr. Chen's team discovered that each ship developed slightly differently, adapting to its specific conditions and challenges. The Nexari, who had always valued uniformity, struggled to accept this diversity until they realized it made their fleet stronger as a whole. Tom Chen, whose radical idea had helped save the Nexari civilization, worked tirelessly to document and understand these variations. "It's not just about survival," he explained during a global briefing. "We're witnessing the evolution of technology itself." The Nexari High Engineer, addressing the United Nations, displayed colors of deep gold and silver. indicators of profound respect in their species. "We came to Earth believing ourselves superior," they admitted. "We leave having learned that true perfection lies not in flawlessness, but in the ability to adapt and grow." Survival through adaptation. The transformation of the Nexeri fleet became the largest engineering project in human history. As ships underwent their controlled reconstruction processes, Earth's cities played host to thousands of crystalline beings, creating unprecedented opportunities for cultural exchange. In Singapore's Advanced Technology Center, Dr. Sarah Chen worked alongside the Nexeri High Engineer, their unlikely partnership symbolizing the bridge between two fundamentally different approaches to technology. The High Engineer's crystalline form now regularly displayed patterns of green and gold, colors of growth and discovery. "Each vessel develops its own unique characteristics," they observed, studying the data from the latest transformation. "Like your Earth species, they adapt to their specific environments." Maya Patel's materials science team had expanded, now including both human and Nexeri researchers. They discovered that the transformed ships could integrate new materials they encountered, strengthening their structures in ways neither species had imagined possible. "It's like they're learning," Maya explained during a global conference. "Each adaptation makes them more resilient, more capable of handling unknown challenges." The Nexeri Engineering Council, once the strongest opponents of the human solution, became its most enthusiastic supporters. Their rigid thinking patterns began to shift as they witnessed the benefits of controlled imperfection and adaptive technology. Tom Chen led a joint human-Nexeri team in developing new interfaces that allowed direct communication between crystalline consciousness and the evolved biomechanical systems. "The ships aren't just transport anymore," he reported. "They're becoming true partners in exploration." In Kenya, Dr. Okafor's research facility became a hub for studying the parallels between Earth's natural adaptation mechanisms and the new Nexeri technology. Young engineers from both species worked side by side, learning from each other's perspectives. "Nature has been conducting engineering experiments for billions of years," she told her mixed species team. "We're just beginning to understand how to apply those lessons to technology." The breakthrough came during the transformation of the Nexeri flagship. As the massive vessel underwent its reconstruction, something unexpected happened. The ship didn't just adapt, it began to exhibit signs of genuine intelligence, forming a symbiotic relationship with its crew that transcended the original design parameters. "It's responding to their thoughts," Dr. Cooper observed, monitoring the ship's neural patterns, "not just following commands, but anticipating needs, suggesting alternatives." The Nexeri High Engineer's color shifted to deep violet, a sign of profound realization. "We sought perfection in isolation," they said. "You showed us perfection through connection." As more ships completed their transformation, a new understanding emerged. The Nexeri fleet was becoming more than a collection of vessels. It was evolving into a living network, each ship unique but connected, much like Earth's own ecosystems. Admiral Harrison, watching the transformed ships navigate Earth's orbit with unprecedented grace, smiled. "They're dancing," he said. "We taught them how to dance." The project's success led to unexpected developments in human technology as well. The principles of adaptive engineering, first developed to save the Nexeri, began to revolutionize Earth's own technological development. Dr. Chen's team created new materials that could self-repair and evolve, while Maya's research led to breakthroughs in sustainable energy systems. Tom's work on human-machine interfaces opened new possibilities for environmental restoration and space exploration. But perhaps the most significant change was in how both species viewed the relationship between technology and life. The rigid boundaries between biological and mechanical, between controlled and adaptive, began to dissolve. "We are learning," the High Engineer announced during a joint session of human and Nexeri scientists, their form shimmering with colors of hope and possibility. "That true advancement comes not from eliminating imperfection, but from embracing the wisdom of uncertainty." A new beginning. 5 years after the first Nexeri ships darkened Earth's skies, the Sol Nexeri Engineering Academy opened its doors in Geneva. The massive structure, itself a hybrid of human and alien architecture, stood as a testament to how far both civilizations had come. Dr. Sarah Chen, now serving as the Academy's first director, stood at the podium during the opening ceremony. Behind her, the transformed Nexeri flagship hovered in the sky, its biomechanical surface rippling with patterns that would have been impossible in its original form. "We gathered here initially as two species facing a crisis," she began, addressing the mixed audience of humans and crystalline beings. "We emerge as partners in pushing the boundaries of what technology can be." The Academy represented more than just a training facility. It was the culmination of a revolution in technological thinking that had transformed both civilizations. The Nexeri, once bound by their pursuit of perfect order, had embraced the power of controlled chaos and adaptation. Maya Patel led the Academy's Advanced Materials Division, where her team continued to discover new applications for adaptive technology. "Every flaw we introduce," she explained to a group of young students, their crystalline forms shimmering with curiosity, "creates an opportunity for growth." The changes went far beyond engineering. The Nexeri civilization itself had begun to evolve, their rigid social structures giving way to more dynamic, adaptable systems. The younger generation of crystalline beings displayed color patterns their ancestors had never dreamed possible, signs of new ways of thinking, of seeing the universe. Tom Chen, heading the Neural Interface Department, worked with teams developing technologies that could bridge not just mechanical and biological systems, but different forms of consciousness itself. "We're not just building better machines," he would say. "We're creating new ways of understanding each other." The high engineer, their form now permanently shifted to include swirls of Earth sky blue, had become a leading advocate for what they called evolutionary engineering. Their speeches to joint human Nexeri councils emphasized how the crisis had revealed a fundamental truth. True resilience comes from embracing change. Dr. Okafor's research into biological adaptation mechanisms continued to influence the development of new technologies. Her work with Nexeri scientists led to breakthroughs in environmental restoration technology, helping both Earth and distant Nexeri colonies recover from centuries of industrial development. "Life finds a way," she would tell her students, quoting an old Earth movie with a smile. "Our job is to help technology do the same." The transformed Nexeri fleet became the backbone of a joint exploration initiative. Each ship, now a unique blend of ordered precision and adaptive flexibility, carried crews of both species into the unknown reaches of space. They discovered that their new technology was better suited to handling the unexpected challenges of deep space than anything either civilization had developed alone. Admiral Harrison, watching the launch of the first joint expedition, reflected on how far they'd come. "We thought we were saving them," he said to Dr. Chen. "In reality, we were saving each other." The Nexeri's journey to Earth had begun as a desperate search for survival. It ended as something far more profound, a testament to the power of diversity, adaptation, and the courage to embrace imperfection. Their crisis had forced both species to confront their limitations and prejudices, leading to innovations neither could have achieved alone. As the Academy's first class of graduates, human and Nexeri alike, prepared to embark on their own journeys of discovery, Dr. Chen found herself thinking about the future. The universe was vast and full of challenges neither species could predict, but they faced it together, armed with technology that could grow, adapt, and evolve. The high engineer, addressing the graduating class, displayed colors that represented a concept their species had only recently learned to embrace: hope in uncertainty. "We came to Earth believing we had achieved perfection," they said, their crystalline form refracting sunlight in complex patterns. "We leave understanding that perfection is not an end state, but a journey of continuous growth and adaptation." In orbit above Earth, the transformed Nexeri ships danced through space, their movements a perfect blend of precision and creativity, each vessel unique, yet part of a greater whole. Like the two species who had created them, they had found strength not in rigid perfection, but in the beautiful complexity of adaptation and change. The story of the Nexari crisis became a cornerstone of education for future generations of both species. It served as a reminder that sometimes the greatest innovations come not from striving for perfection, but from having the courage to embrace imperfection and the wisdom to learn from it. The end.